Hi, in this video we'll be looking at algebraic expressions and the symbols and variables that are contained within these. We'll be looking at exponential notation, and we'll be looking at how we simplify and evaluate expressions using what is known as the order of operations. The order of operations is a very important idea, and that is the central focus of this video. Make sure you understand the order of operations and how to use them. We'll also be looking at identifying and combining like terms in expressions in order to simplify expressions. Okay, so let's get started. We work with expressions a lot in algebra. So for example, we have expressions like this one. Let's say x plus 4. Well, x is a letter, as is obvious, that represents a number, and that number can change. And so we look at this more deeply as we move along through the course. Sometimes we might use letters also to represent constants. So constants are numbers that don't change. Of course, if you want to represent that number, then you just write the number. But I'm sure you've seen this before, let's say in high school. Y equal mx plus c. So this is a good example. So in a case like this, we're dealing with values that can change. X can have different values, and then y will have a different value depending on what the value of x is. However, m and c are not expected to change, so these would be your constants. So how do you know which letter represents a variable and which letter represents a constant? Well, that comes from familiarity with whatever it is that's being discussed. And so don't make a big deal about that, right? Just remember that we use letters to represent variables and we use letters to represent constants. And constants are values that don't change, and variables, well, their value can change, under a given circumstance. Four very important operations that we use are addition, subtraction, multiplication, and division. So the symbols we use for addition and subtraction, well, you are most likely very familiar with them. Multiplication, you are probably used to the times sign, which is a little x. So we might say a times b. But the problem with that is that this x, well, it looks like x, and so it can cause a confusion. So when we're using like letters, you probably don't want to use this times sign, and so you can use a little dot, right? Or you can just place the letters beside each other. Sometimes it becomes important to use grouping, and so you can do the same thing by saying, a times b, like that. You can also say a times b, like that, and so on. Now there's another symbol that we can use, and especially if you're working like with Excel or writing a program, and that's the symbol that looks like an asterisk. So when doing algebra on paper, we don't tend to use the asterisk sign, and that's not a very good looking asterisk. But anyway, you kind of know the asterisk, right? So just be aware of this, right? When it comes to division, you're used to the sign here, the divide sign that looks like this. So you can say a divided by b. Often we just simply say a over b, like this, to say a divided by b. We can go like this, but this is not something we'll do a lot. But this is also saying a divided by b. And we can of course use the slash, a divided by b, like this. Right, so make sure you're aware of these. Here are some more symbols you need to know. So the equality symbol is one that you are, I am sure, very familiar with. And so I can have, say for example, x equal 5. We could also write something like, say, x plus 1 equal 3. In this case, it should be very obvious to you that x then has to have a value of 2 for this to be true, right? If x was made equal to, say, 0, then this would be a false statement, right? Because 0 plus 1 gives us 1. 1 equal to 3 is a false statement. Now there's one other symbol that is related to this one that I want to introduce here, and we'll see it again later on. let's suppose I have 2x plus 1 like this, and then I say, well, that's equal to 2x plus 2. Now notice if you make x 0, you have 2 on this side and 2 on this side. If I make x 1, I have 1 plus 1, 2, 2 2 is 4, 2 1s 2, plus 2 4. And you can continue looking at this and you're going to realize that no matter what value of x, no matter what value we assign to x, these two expressions will be equal. The results that we get on both sides will be equal. So instead of using an equality symbol as we have here, what we should use is an identity symbol. And so we'll go into this in more detail later on, right? This is an equality symbol, and now what I have here is an identity symbol, which is these 3 horizontal bars. Moving on, we need to look at inequality symbols, and so we have these 5. So I don't think you need introduction to these. This is saying that a and b can't have the same value. So a can be any value as long as it's not whatever value b has assigned to it. Here we're saying that a can be any value that's less than b. A can be any value that's less than b or equal to b, and so on. And of course you have your grouping symbols. So you have your parentheses, your brackets, and your braces. I have been using the word expression from the very beginning of this video, so now let's properly define it. An expression is a number, a variable, or a combination of numbers and variables using operation symbols. So here we have 3 plus 5 and n minus 1, and we can think of these as English phrases, not sentences. So this would be the sum of 3 plus 5, this would be the product of 6 and 7, this would be the quotient of x and y. So an equation is simply 2 expressions connected by an equal sign. So notice now what we have is a full sentence. We have the sum of 3 and 5 is equal to 8. The difference of n and 1 is equal to 14. The product of 6 and 7 is 42. X is equal to 53. And the sum of y and 9 is equal to the difference of 2y and 3. Exponential notation allows us to easily express the fact that a number multiplies itself a certain number of times. So for example, if you want to say the number 5 multiplies itself 6 times, you could, if you wanted to, say 5 times 5 times 5 times 5 times 5 times 5. So that's 1, 2, 3, 4, 5, 6. You could say it like that, but obviously writing it this way is a lot easier. So this is called the base. The number 5 here is the base, and 6 here is the exponent. Alright, so I think you should be very familiar with this. Now we look at order of operations and how we can use the order of operations to simplify expressions. So at the end, we find ourselves always having to do calculations or having to have calculations done. Now, there was a time when all calculations were done by humans, but in this day, I would say most calculations, almost all calculations are done by computers. So in the past, it was important to understand the order of operations so that you could carry out your calculations effectively. Now, it is important to understand your order of operations so that you can properly instruct a computer to carry out certain calculations. In fact, you could say it's probably even more important now because a computer can do millions of calculations in the blink of an eye, and this would be then millions of things that are wrong if the proper instructions are not given. So it's important. I can't emphasize this enough. For this lecture, this is probably the most important idea, how to use the order of operations. And so what are the various operations that we'll be looking at? For now, we look at some simple ones, right? Just the basic addition, subtraction, multiplication, division, and then raising things to a power. As you probably know, when you raise something to a power, it's like you're doing a lot of multiplications. Like 5 to the 3rd power is 5 times 5 times 5. And then there's grouping, right? And the what grouping does is helps you to specify the order in which you want certain operations to be done. So let's suppose we have let's just take a look at this and see why this is important. Suppose I have 3 times 5 minus 1. Well, according to our order of operations, multiplications come before subtractions. So there are only two operations here, and so a computer has to decide, well, which one to do first. Should it say 3 times 5 or should it say 5 minus 1? Well, given how this is written, multiplication has a higher level of priority than subtraction, so this has to be done first. So then we say 3 times 5, 15 minus 1, and then now this gives me 14. Now suppose you didn't want that. You wanted, for some reason, you wanted 5 minus 1 to be done first. Well, the only way you could get that to be done in the way that you want would be to say, well, then you have 5 minus 1 here, but in parentheses. Now, notice the parentheses are at the top of this hierarchy here, right? Parentheses have to be done first. And so now the computer will come along and say, oh, I'll subtract 5 minus 1, and that would give me 4. And then 3 times 4 would be 12. So notice how we get different answers. So this is very important. I can't stress this enough. Let's take a look at another example here. If I have 8 minus 6 plus 4. So now you have a minus and a plus, and the computer needs to decide, well, which to do first, 8 minus 6 or the 6 plus 4. Well, if you check here, addition and subtraction are at the same level. Now, sometimes students learn this improperly, right? Some students I have found coming into my class have this idea that addition comes before subtraction, so the addition has to be done first. No. When you have addition and subtraction like this, the one on the left gets done first. So here, the subtraction gets done first, right? So 8 minus 6 gives me 2 plus 4, and then the answer then becomes 6. So I'll be giving you quite a number of problems like this for homework, you know. If I have 8 minus 2 to the third power plus 4, and then 45 divided by 3 times 2. So the computer comes along now and, well, which operation do I have to carry out first? Well, we see some parentheses here, so the parentheses need to be addressed first. But I have two of them. Well, parentheses are at the same level, and so then you have to work from left to right. You have to tackle this parentheses first. Now, sometimes you might have a system where you have, let's say you have 3 plus 2 minus 6. Well, then you have to tackle the inner parentheses before you tackle the outer parentheses. Right? So we'll see maybe an example like that later on. So which operation gets done first? So now when I ask, you know, in class which operation gets done first, don't tell me parentheses, because that's not really saying anything, you know. Should we say 8 minus 2? You know? Or should I say 2 plus 4? Or should I say 3 plus 4? Or should I say 45 divided by 3? Right? So you have to decide. Another way of writing this would be like this. Let's suppose you're doing this in Excel. In Excel, you'd write this way. See? So now you can see the problem, right? It's not so clear now, right? Should I say 3 plus 4? Right? Or should I say 8 minus 2? Right? Here you might say obviously not, but here it's not so obvious anymore, perhaps, right? This means 2 to the third power, right? That's how it's written in Excel. So let's get our rules. Parentheses have the highest priority, and then we have two sets of parentheses, and so we need to do the leftmost one first. And so that's this one. And so in here we have what? A subtraction, an addition, and an exponent. Well, the exponent comes before these, notice? And so we have to do this first. So this becomes 8 minus 8 plus 4. And then that's 45 divided by 3 times 2. So we're doing one operation at a time. So again, we have to tackle this parentheses first. So we have a subtraction and an addition. Which comes first? Well, these are at the same level, and so we have to do the subtraction first. All right. And so 8 minus 8 gives me 0. All right. And if we continue here, we still have this parenthesis here, so we have this. By the way, there's a multiplication here that I haven't mentioned, right? There's also the multiplication between these two groups. So we need to tackle this parenthesis. 0 plus 4 gives me 4. I don't need a parenthesis anymore, but let's keep it. And then I have 45 divided by 3 times 2. So now I have a parenthesis here, but there's no operation in here, so there's nothing to do here. So now I come to this one, and I have a division and I have a multiplication. Which should I do first? Well, the leftmost one, because these are at the same level of priority. So be aware of that. Sometimes I get students who somehow they were taught that multiplication comes before division, and I think it's because maybe it's written this way, So then this becomes 4 times 45 divided by 3 is 15 times 2. Notice? And then now 15 times 2 is 30. And now 4 times 30. So this is the last operation. So in a question, I'm in a quiz, so I may give something like this and say, well, what's the first operation? And the first operation will be what? 2 cubed. Raising 2 to the third power. What's the last operation? Well, it's going to be 4 times 30, which gives me 120. Now, you may argue that you could have done it differently or something and gotten the same answer. And that's fine, but I'm just telling you what the rules are, right? And you need to be aware of this. Okay, so we'll see more of this in class, right? If you do class with me. When we are asked to evaluate an expression, we're given numbers that then we substitute into the expression. In other words, we replace the variables in the expression with those numbers. So let's suppose, for example, we have the expression x plus 20 divided by square root of y squared plus 9. And we're asked to evaluate this. Well, if you're asked to evaluate an expression, you have to be given values. So let's say x is 40 and y is 4. Well, now that simply becomes then 40 plus 20 divided by the square root of 4 squared plus 9. So let's use our order of operations to do this. Right? Sometimes it becomes not so easy to see when it's written in this format, and it may help to write it out as I'll do here. 40 plus 20 divided by square root of 4 squared plus 9. Now, if you're using something like Excel, for example, you can't use a square root sign like this. You have to use a function like squirt or some other way. And there's another way we could do this. But for right now, let's look at this. And the thing I want to point out is that this square root sign acts also like grouping. So, for example, we talked about parentheses, braces. Well, the square root sign is also like acts as a grouping operator also, right? It's telling us that all of this is grouped. You can't just find the square root of 4 squared. You have to find the square root of everything in here. In other words, you have to carry out this operation first before you apply this square root sign. You have to carry out what's in here. All right. So another important thing is that when you're writing out this way, when you look at something like this, rather, you don't see a parentheses up here. These parentheses are not needed, right? Because this bar also acts in a sense like a grouping operator. What's up here forms one group and what's down here forms another group. Sometimes students aren't aware of this. So when you have to say put something like this into Excel, you might be tempted to just say 40 plus 20 like that. But that's going to be a mistake, because then Excel will simply divide 20 by this. It won't add this first and then divide. So it's very important to understand then that sometimes grouping is implied. You don't actually see a grouping sign like one of these, you know, like the brackets or the braces or the parentheses. But so you have to understand that there is an implied grouping here, and of course there is an implied grouping here also with the square root sign. So what gets done first? Well, we have two groupings, and the leftmost grouping has to be done first. When you see it this way, you need to realize that this 40 plus 20 would be your leftmost grouping. So then this needs to become 60 over the square root of 4 squared plus 9. Now we have to come and take care of this grouping here. And inside here we have an addition and an exponent, which needs to be done first. Well, the exponent, so that's 60 over the square root of 16 plus 9. And again, we're still inside this grouping, so that's 60 over the square root of 25. And now we're still inside this grouping, and so that's 60 divided by 5. And so this then gets reduced. If we were doing it over here like this would be 60 divided by the square root of 16 plus 5 plus 9, which is 25. And of course then this becomes 60 divided by 5, which is 12. And so you see that here also. So again, the order of operations then is very important. You need to understand this, and there are different little mnemonics that you can use. I like mnemonics, but in this case it's one I tend to avoid. I think they cause more confusion. So just try and get this without the use of a mnemonic. But I'm not adamant against them either. If it helps, fine. There are lots of them out there. BODMAS, PEDMAS, something of Polly and her aunt or something. I don't know. All right. Algebraic expressions are made up of terms. So here is an example. We might have let's say 5x to the 7th power minus 3x to the 4th plus 11. And so what's a term? A term is a constant, so here is a term, or it's a product of a constant and one or more variables. So here it's 5 and you have x to the 7th power. And in this case we're only working with one variable, but it could be, we could have more variables. We could have, say, 8xy plus 3x squared plus 2y squared minus 16. Again, this is a term. These are all terms, right? And so what's a term? It's either a constant, a number, or the product of a number and one or more variables. So when you have the product of a constant and one or more variables, that constant is referred to as a coefficient. So here the coefficient is 5, and here the coefficient is 3. Very often we find ourselves needing to simplify expressions. So let's suppose we have an expression like this one. We have this expression, 2x squared plus 3x plus 7 plus x squared plus 4x plus 5. We can simplify this by looking for like terms. So when are terms said to be like terms? Well, whenever they are constants. So this 7 and this 5, these are like terms because they're both constants. Or when the terms have the same variables and every variable is raised to the same powers. So like terms that are either constants or have the same variables raised to the same powers. So here, what are the like terms then? Notice this has an x and this has an x. This has an x, but this is not raised to the same power. So the only ones raised to the second power are these two. So that's 2x squared plus x squared. I can simplify those. It's like 2 of something and 1 more. So I have 3 of whatever that is. And then x's, I have 3 x's and 4 x's. That gives me 7 x's. And I have this 7 and this 5. That's 12. So I hope this is clear. Again, we'll practice more of this if you do classes with me. So for now, I think this is enough for this video. So I'll say goodbye.